Hi all, today's session is about chemical properties of alcohol. So over here, when you say chemical properties, the cleavage will take place in two sites. So these two are cleavage sites. If you take an alcohol, so for example ethanol I have written here. So alkyl group is binds with oxygen, right? So the bonding over here, the cleavage will take place over here between carbon and oxygen, and also the cleavage over here between oxygen and hydrogen. So these two are cleavage sites. So over here oxygen is a electron rich species. So that's why partially negative, and the carbocation is partially positive. Same hydrogen ion is partially positive. So under this subtopic, chemical properties of alcohol, we'll learn reactions involving cleavage of OH bond. So what are all the reactions will take place when the cleavage takes place between O and H? When the cleavage takes place between O and H. So acidic nature of alcohol, reactions with active metals, esterification, and reaction with acid chlorides and acid anhydrides. So these are all the reactions involving cleavage of OH bond. And the reactions involving the cleavage of COH bond, that means between the carbon and the OH. So this bond. So this will take place in reaction with hydrogen halide, and reaction with phosphorus halide, and reaction with thionyl chloride. And the next one is reactions involving both alkyl as well as hydroxyl group. So both the alkyl group and the hydroxyl group, both will react together. So both will react in the reaction. So those type of reactions are dehydration and oxidation. So in this session we are going to see all these reactions. So you have to know what reaction is involved, which cleavage involves in each reaction. Okay, yeah. So now we'll move on to reactions involving cleavage of OH bond. So the first one, acidic character of alcohol. Alcohol acts as a weak acid, so it ionizes. So alcohol acts as a weak acid. How it acts as a weak acid? So when will you say it is an acid, when a substance is an acid? So when it donates a proton, right? So over here ethanol, I have given ethanol. In ethanol, hydrogen donates hydrogen. So the cleavage is taking place between oxygen and hydrogen, right? So you will get oxide, eth oxide and hydrogen ion. So the cleavage is taking place between oxygen and hydrogen. So that means it's a proton donor. That's why we are saying it as acid, and it's a weak acid. Oxygen atom being more electronegative, it pulls a shared pair of electrons of OH bond. So it pulls the electrons of OH bond, so that oxygen is electron rich, we know, and over here this pulls the oxygen towards it, so the hydrogen ion becomes weaker. So OH becomes weak, OH bond becomes weak, so that hydrogen ion releases. So alcohols are weaker acid than water. Ionization constants. Why why alcohols are weaker acid than water? So ionization constant of alcohol, this is the range 10 to the power minus 16 to 10 to the power minus 18. But for water it is 10 to the power minus 14. So it is less than the water. So water and alcohol possess similar structure. So like HOH, ROH. So similar structure only, but still R is the electron releasing group because carbocation, right? So which will form carbocation. So alkyl group is a electron releasing group. So this decreases the polarity between polarity of OH bond. So when this decreases, that is why this is less than water, less acidic than water. So acidic strength of alcohol: primary is more acidic than secondary, and secondary is more acidic than tertiary, because number of alkyl group increases. When the number of alkyl group increases, the polarity decreases. So here if you see, this is primary alcohol. Over here this is most acidic. The reason, the less pull between over here. So the electrons which donate by the carbocation, because this is also electron leaving group, right? So this donates electron to oxygen. So less number of electrons moves to oxygen. So more pull over here. That is why it is more acidic. So more pull between the oxygen will pull electrons towards it from the hydrogen. So this is most acidic. So over here polarity more polarized. This one secondary. When compared with this two alkyl group, so both the alkyl group will donate electrons, so that less pull than primary. So same way like tertiary. So that is why tertiary alcohol is least acidic. Okay, yeah. Next, reaction with active metals. Under this we have only sodium. So when sodium reacts with alcohol, so when sodium reacts with alcohol, we'll get sodium ethoxide and hydrogen. So over here again it acts as an acid. So ethanol acts as an acid, so that when it reacts with sodium, a metal, so what will happen when acid reacts with a metal? You will get a salt and hydrogen evolves. Same reaction takes place over here. Hydrogen evolves from the product. So esterification. Esterification we have learnt already. It's a reaction between alcohol and acid. So over here concentrated H2SO4 acts as a dehydrating agent, and also it is a protonating agent which donates proton. So over here when the reaction takes place, the water molecules releases because it's a dehydrating agent. So you will get the ester. So esterification we all have learnt already. And the reaction with acid chlorides and acid anhydrides. So acid chlorides or azyl, we'll say azyl chlorides or acid anhydrides. So over here this reaction will take place in the presence of pyridine or dimethyl aniline. Pyridine, a benzene ring with a nitrogen, or dimethyl aniline, N with 2 methyl group and benzene. So dimethyl aniline. Okay, so the hydrogen of NH2 replaced by alkyl group. So either this or this acts as a catalyst. So this reaction is same like esterification, but over here the byproduct is HCl, not water. So same type of reaction, in the presence of pyridine you will get ester and HCl evolves. So if it is anhydride, again acid anhydride, so same way, but the same type of reaction, but the byproduct is acid. So ester and acid you will get if you use acid anhydride. This reaction is otherwise called acylation or acetylation. Okay, yeah. Next, so reactions involving cleavage of carbon OH bond, so carbon and hydroxyl bond. So over here the reactions which is more reactive, tertiary, then secondary, then primary. So over here number of alkyl group increases, same like whatever we have seen in the previous subtopic. Number of alkyl group increases, polarity increases. So easier to cleave. When the number of alkyl group increases, easier to cleave. So tertiary, it's easy to cleave. So over here reaction with hydrogen halide. So order of reactivity, tertiary more reactive, secondary less than this, and primary less than that. And then if you take order of reactivity in hydrogen halide, so over here HI is more reactive than HBr, and HBr is more reactive than HCl. So over here zinc chloride, we use zinc chloride as a dehydrating agent, anhydrous zinc chloride. This reaction already we have seen in the previous chapter, so where we have used how to prepare alkyl halide from alcohol. So alcohol with HCl in the presence of anhydrous zinc chloride, by heating this you will get a chloroalkane. So water evolves as I have showed in the reaction. So over here if it is a secondary alcohol, same catalyst, so if it's a secondary alcohol you will get secondary chloride. So over here 2-chloropropane. So if it is tertiary alcohol does not need any catalyst, and this occurs at room temperature. Over here we need to heat this mixture, but over here this will take place at room temperature. So over here there is a tertiary alcohol. When it reacts with HCl at room temperature, you will get 2-chloromethylpropane. The same way over here a different hydrogen halide, hydrogen iodide I have mentioned here. So when hydrogen iodide reacts with any alcohol in the presence of red phosphorus, this also already we have learned in the previous chapter. So in the presence of red phosphorus you will get alkane, and it iodine evolves and water vapor evolves, right? Yeah. Next is about reaction with phosphorus halide. Okay, a reaction with phosphorus halide. This also we have seen already, because from alcohol, how will you prepare halogenoalkane from alcohol? This again we have seen in the previous chapter. So we'll move on quickly. So alcohol with PCl5 you will get chloroalkane with POCl3, phosphorus, oxychloride and HCl. And if it is a PCl3 or PBr3 or PI3, 3 moles of alcohol you have to take, so that 3 moles of alkyl halide you will get, and you will get the phosphorus as a byproduct. But over here PBr3 and PI3 are unstable, so that we have to use phosphorus and bromine and phosphorus and iodine mixture, so that immediately that prepares PBr3 and PI3, and you can use it as a reactant. Okay, so there are reactions with thionyl chloride. I said sulfur dichloride oxide, right? Thionyl chloride, otherwise called thionyl chloride. This, when it reacts with alcohol in the presence of pyridine, you will get chloroalkane, and SO2 it releases sulfur dioxide and HCl gas. So it is easy to get the product, pure product. Okay, yeah. Next, reactions involving both alkyl as well as hydroxyl group. So reactions involving both alkyl as well as hydroxyl. This is the third subtopic. Again, very important one. Dehydration. Dehydration in the presence of H2SO4 or H3PO4. Concentrated sulfuric acid or concentrated phosphoric acid at 433 Kelvin. So when alcohol reacts with H2SO4, over here H2SO4 is a protonated alcohol. So this this will protonate the alcohol. So by protonate, in the sense the hydrogen will react over here, and this will give a protonated alcohol, right? This protonates, sulfuric acid protonates the alcohol, so that you will get protonated alcohol. This is the first step, and this is a very important mechanism in this chapter. And the protonated alcohol loses water molecule, so that you will get a carbocation. The carbocation reacts with another unprotonated alcohol, so that you will get a complex. This complex, when it loses a proton, you will get ether. So this ether is diethyl ether, ethoxyethane, right? So over here, dehydration can give two different products. So you will get ether, or you will get alkene. So how will you get alkene? Same process. Again, when H2SO4 reacts with alcohol, H2SO4 protonates the alcohol, so that you will get the protonated alcohol. And protonated alcohol, again, when it loses the water molecule, you will get carbocation, and then the carbocation releases the proton. By releasing the proton, you will get CH2 double bond CH2, alkene. Okay, and same dehydration will take place with the presence of alumina, Al2O3. Same type of reaction. At 633 Kelvin, this leads to alkene, and at 523 Kelvin, this leads to ether. That's the only difference. Other than that, same type of reactions. Then oxidation. Oxidizing agents, we have learned this already, right? Last year itself. Oxidizing agents are alkaline KMnO4, acidified K2Cr2O7, and acidified Na2Cr2O7, nitric acid, and chromium trioxide. These are all oxidizing agents. You can use any one of these oxidizing agents for oxidation. So over here, the cleavage takes place between CH and OH bond. Right? So primary alcohol leads to aldehyde, on further oxidation leads to acid. So we have learned this already. A primary alcohol, when the oxidation takes place, that leads to aldehyde. Again, on further oxidation, that will give you acid. If it's a secondary alcohol, that leads to ketone, and the ketone on vigorous condition, under vigorous condition, this leads to acid. So over here, 3 carbon atoms, so that over here ethanoic acid and methanoic acid. So tertiary leads to ketone, and then on vigorous condition, under vigorous condition, that also leads to acid, carbon dioxide and water. So over here, this gives a tertiary alcohol. On vigorous condition, will get a ketone, and the ketone on a vigorous condition, because HNO3 is a strong oxidizing agent, so that you will get CH3 and COH and HCOH. On further oxidation, the COOH also dissociates into carbon dioxide and water, so that you will get tertiary leads to acid, carbon dioxide and water. So this is what, so we have seen all the 3 types of reactions today. So again, I'll recollect the concept to you. This is about the chemical properties of alcohol, because alcohol has 2 cleavage sites. So alkyl group, and between alkyl and alcohol, and between the oxygen and the hydrogen. So cleavage can take place in these 2 sites. So over here, 3 different types of reactions involving O and H. So we have seen acidic nature, so that hydrogen releases from the ethoxide or alkoxide, and same way active metal reacts with the oxide, and esterification also, hydrogen alone leaves from the alcohol, and reaction with acid chloride also same way like esterification, only hydrogen ions releases. That is why the hydrogen releases from the alcohol. That is what? Reaction involving cleavage of OH bond. And reaction involving cleavage of COH bond, reaction with hydrogen halide we have seen, and over there the alcoholic group COH group cleavage takes place over here, and the OH is replaced by Cl. Same way everything, OH replaced by the halogen group. So the bonding between C and OH, like over here. And the reaction involving both alkyl as well as the hydroxyl group, dehydration and oxidation. Dehydration again, so when the dehydration takes place, this becomes alkene and this becomes a water. So both the alkyl group and the hydroxyl group takes place. And oxidation, again oxidation also over here, in both the cases alkyl group as well as hydroxyl group, the reactions takes place. So this is what about chemical properties of alcohol. Very important topic, children. So revise it properly, read the textbook. So few topics are unnecessary. The whatever the topics over here which we covered is in syllabus. Thank you, children, for watching. Bye bye.